Hi guys, welcome to SuperChem video lessons on organic chemistry. This is our third lesson on organic chemistry, and then in this lesson we are going to learn how to name hydrocarbons, specifically branched chain alkanes. Previously, in the second lesson, we learned how to name straight chain alkanes. We got to know that, for example, in naming a straight chain alkane like this one, you need a root word and then a suffix. In this example, the root word would be hex, since the number of carbon atoms is 6. And then because they are all single bonds, we know it's an alkene, so the suffix is ane, and then we put the two together and we get hexane. So that was how we got to know how to name straight chain alkanes. But in this video, in our quest to name branched chain alkanes, we are not only going to need a root word and then a suffix, but there is something new here: prefix. Alright, you'll get to know the need for this prefix in a bit. What is the difference between a branched chain alkane and a straight chain alkane? A branched chain alkane has a branch. Check out this example. You see that we have a long chain of carbon atoms, but on the second carbon atom in the long chain, realize that there is one carbon atom that is appending from the second one, that is found on top of the second one. Normally we know that it should be a hydrogen atom that is here, but it has been replaced by this carbon and its hydrogen atoms that are surrounding it. So this carbon together with the hydrogen atoms is forming a branch which extends from the parent chain. So this carbon atom and its hydrogen atoms together, we call them a substituent. They are together called a substituent. And then the long chain of carbon atoms is called a parent chain. So in naming branched chain alkanes, you need to know the substituent and then the parent chain. Alright, so that is the reason why we have a prefix here. The prefix will tell us the type of substituent that we have, and it will also tell us the location of the substituent in the parent chain. And then our root word will depend on the number of carbon atoms in the longest chain or in the parent chain. And then because we are dealing with an alkane or alkanes, our suffix or our ending will be ane. Okay, so prefix plus the root and then the suffix will give us our name for any branched chain alkane. Alright, now let me talk more about the substituent. A substituent is an atom or group of atoms which replace one or more hydrogen atoms on the parent chain, that is the longest chain of a hydrocarbon. Check out this example down here. This is an example of an alkene which has a substituent. You realize that the substituent is Br in this case. It is replacing one of the hydrogen atoms that the carbon should have. And you realize that here it is only one atom. So a substituent can be just one atom, or in this case, it can be a group of atoms. Here we have CH3, being our substituent, is a group of atoms. In our lessons, we are going to deal with this kind of substituents, CH3. These are the kind of substituents we'll be dealing with. We call them alkyl group. So CH3 is a member of the alkyl group. Talking about alkyl groups or alkyl substituents, here are some examples. What you have seen now is CH3. The name is methyl. Why methyl? Because it has one carbon. So if your substituent has one carbon, then it is what? Methyl. If it's having two carbon atoms, then it's ethyl. 3 is propyl. 4 is butyl. And then 5 carbon atoms would be pentyl. So these are some common alkyl substituents that you can have. Alright, so before we get started with naming our first example of branched chain alkane, I want to let us know that most of the examples we'll be looking at will be in the condensed structure form. This is an open structure, but we can derive a condensed structure from it. In order to save space, normally we use condensed structure formula. Like in this example, the first carbon has 3 hydrogen atoms. So in the condensed structure formula, you write the carbon and you surround it with the 3 hydrogen atoms as is done here. Then you bring a bond, then you move on to the second carbon. The second carbon has 1 hydrogen atom beneath it. So you show it here, CH. And then on top of it, we have a substituent, CH3. C with 3 hydrogen atoms. So the substituent is on top of it. You bring a bond and you show the substituent. Then you come back and you continue the journey. So the next carbon has 2 hydrogen atoms. So here is it, carbon with 2 hydrogen atoms. The next one has carbon with another carbon with 2 hydrogen atoms. Okay, so that is it. Then the last carbon has 3 hydrogen atoms. So there you have it. This is an open structure formula, and this is how you write its condensed structural formula. This is another way of writing the condensed structural formula, but we are going to deal with this one the more. Alright, so this is something to tease you before we start working on our first example. Check this out carefully. Look at this example. This compound, do you think is a straight chain alkane or a branched chain alkane? Check it out carefully. Alright, so there you have it. It's a straight chain alkane. I know some people might think that because there is a curve here, when you start from here, you see that there is a curve, so they might think this is a branched chain alkane, but it is not. For a branched chain alkane, you should begin from one carbon atom, and then as you are continuing, there will be a branch away from the long chain. But this one, everything together is just a single chain, so it is not a branch chain alkane. When you start looking at our examples, you understand this better. Alright, so here is our first example. Okay, so check out this example very well. In naming straight chain alkanes, you first have to know your parent chain. Your parent chain is going to be the longest chain. So you can have 2 or more chains in a compound. For example, in this one, you can have 2 chains. When we start counting from here, 1, 2, 3, 4, this is 1 chain. You can also start counting from here, 1, 2, 3, 4. So because our chains in this case they have the same number of carbon atoms, we can choose any of them to be our parent chain. So let's take this one, the straight one. So let's go straight, and let's make that our parent chain. So when we choose this as our parent chain, then the rest will be our substituent. So the parent chain, you can name it like the way we name straight chain alkanes. So here you have 4 carbon atoms in the parent chain. So you give it the root word but because they are 4 carbon atoms. And then they are all single bonds. So the ending is "-ene" because they are alkanes. So looking at the parent chain, we know that we have a butane here. Butane. So when you get this done, then you move on to the substituent to know the prefix you have to use. As I said, the prefix tells us about the substituent. So here you can see that our substituent is CH3, and we know that CH3, from this table, CH3, the name for CH3 is what? Methyl. So our substituent is methyl. Then the next thing you have to look out for is its location. Where is it located in the parent chain? Here you can see that it is located on the second carbon. So you put 2 in front of it, which tell you where you can find the substituent. So the prefix is 2-methyl. When you add it to the root and then the suffix, you get the name 2-methyl butane. Okay, so here we have our second example. Alright, so once again you have to check your parent chain. So you can start counting from here. 1, 2, 3, 4, 5. 5 carbon atoms in this straight chain of carbon atoms. So it is 5. But you can also try to count from here and see. 1, 2, 3, 4. So this is 4. When you count from here is 5. So which one do you choose? The longest chain, which is 5. 5. This straight chain, which has 5 carbon atoms, is our parent chain. So you first name your parent chain. It has 5 atoms, so it's going to be what? Pent and ene, pentane. So here you have it, pentane. Then you move on to your substituent. Okay, our substituent once again is CH3, and the name for CH3 is what? Methyl. But you have to know the location. Okay, it is on the 3rd carbon of the parent chain. Let's count. 1, 2, 3. You have to also count from the back to see if you have a different number for the position. So let's count from here to 1, 2, 3. So from either sides, the carbon that has the substituent is 3. So we have to choose 3. So the prefix is 3-methyl. Adding it to the root and then the suffix, we have 3-methyl pentane. Yeah, so there you have it. That's your second example. Now here is a bigger structure. This is our third example, and in this you have to once again check out your straight chain alkane. So you can start counting from here. 1, 2, 3, 4. You come down 5, 6. So when you count it this way, this is 6. This chain has 6. Okay, when you also count from here, 1, 2, 3, 4, 5, 6, 7. So this is longer than when you count from the left to the bottom. But okay, let's move on to counting from counting it in a straight line. So 1, 2, 3, 4, 5, 6, 7, 8. So when we count it that way, we have 8 carbon atoms. So our parent chain is going to be this one, because that is going to be the longest chain. So we choose this as our parent chain, and then because it's having 8 carbon atoms, is oct, then the ending is "ane" because they are all single bonds. So octane. So with that done, you move on to your substituent. So when you get your parent chain, the rest is your substituent. So which substituent is this? Let's check our table. If the substituent has 2 carbon atoms like this, carbon and carbon, CH2, CH3, it is called ethyl. Okay, so the name of our substituent is ethyl. Then let's move on to finding its location on the parent chain. You can begin from counting from the left. So 1, 2, 3, 4, 5, 6, 7, 8. Our substituent is on the 5th carbon in the parent chain. Alright, so let's count from the other side too and see if you have a different number for the position. 1, 2, 3, 4. When you count from the left, the position of the substituent will be 4. And then we always want to have the smaller number for the location of the substituent. So we are going to choose 4 instead of the 5. So the location should be 4. So our substituent is 4-ethyl. You add it to the root and the suffix and you get 4-ethyl octane. Alright, so here it's our last example. In this example, you have to check out as we have been doing your parent chain. So let's count from here. 1, 2, 3, 4. Okay. Let's also count from here. 1, 2, and go upwards. 3, 4. Okay. So we have 4 and 4. Okay, let's look at our third option. 1, 2, 3, 4, 5. So if you count it this way, our parent chain gives us 5 carbon atoms, which is the longest chain. So we choose that one as our parent chain. So that is going to be our parent chain. 5 carbon atoms it's having. So when you take it out, the rest is CH3, and that will be our substituent. So our parent chain has 5 carbon atoms, so it is pentane. And then our substituent is CH3, and we know the name for CH3. What is it? Methyl. What would be the location for CH3? Let's count. 1, 2, 3. Let's try also counting from down here. 1, 2, 3. So in either ways, the position is 3. So we choose 3. Methyl. Adding it to the root and the suffix, we have 3-methyl pentane. So there you have it. Here are 4 examples we've done for branching alkanes. I hope you can try these structures on your own. With regards to naming them, you can name them. So try to name these ones on your own and let me have your answers. So you can take a screenshot and then try to do them by yourself. Alright, in our next lesson we are still going to continue with naming branched chain alkanes, because we can have very complex branched chain alkanes. So we continue to name branched chain alkanes in our next lesson. Alright, so you hit me up with your answers. Enjoy your day, keep calm and steady.